Finish off this FLSM with the last example. I'll take any A class example now. Let us try to do some A class examples. I'm not going to take 2000. So this 2000 you can use for your homework, and probably you can just go through with this example just for reference. I'll take another example here. So probably I'll take the other example as let's take a more bigger number, so I'll take 32, okay, 64,000. So requirement is I'm going to take 32,000 requirement. Anyway, it's very hard to get such a big number, so probably in the production networks we really don't use such a big numbers, but just to make sure that we are comfortable with the calculations, we are getting into some bigger numbers. So requirement is going to 32,000, and we are using some A class example. So if I just take the formula to the power of h minus 2 greater than or equal to requirement, so my requirement is 32,000, so I'm going to take 32,000. So which value satisfies my condition? 32,000 means if I refer my 2 power table, 2 power 13 is 8192, 2 power 14 16,000, 2 power 15 satisfy my condition. It is 32768. So I'm going to take 2 to the power of 15 value. So 2 to the power of 15 minus 2. So it goes around 32768 to the power of 15. In that, two addresses we cannot use because network ID and the broadcast ID. So valid addresses I can use is, this is my valid host addresses which I can use for any number of devices. Means even though my requirement is 30,000, still I can add 766 devices extra. So from this, if you understand, our required host bits are 15, and converted bits. To find converted bits, we need to know default bits first. By default, A class supports 1 network portion and 3 host portion, which means by default there are 8 and 24. So once you are comfortable with these things, now we can probably find out how many total host bits we have. So to get converted network bits, or we can say small n value, total host bits are by default 24. That is, this is your host bits, this is your network bits. Out of 24, I just need only 15. So which means 9 gets converted. 9 means, so if you just want, I can write one more time, like network means 1, 2, 3, 4, 5, 6, 7, 8. Host means 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. So total there are 24 host bits. Out of 24, I don't need 24, I just need only 15. And remaining 9 I am converting. Or we can say like this, 15 host bits, and remaining 9 I am going to convert. So remaining 9 means, in my example, remaining 9 is 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so 9 in the third portion you can see here. So total becomes, by default there are 8 and plus extra 9 added. 9 means you don't get exactly 9 in one portion, so you get 8 in one portion and 1 in other portion. Okay, so this is your total network bits, or we can say total network bits is equal to, by default there are 8 plus 9 converted, so 8 plus 9 it becomes 17. So now the tally of 8 network and 24 host has been changed to 17 network bits and 15 host bits. Finally it will be 32. So 17 plus 15, 32, but just we are manipulating, we are changing some of the network bits and the host bits as per the requirement. So let's move on with our subnet mask. This is our subnet mask. If I add 8 bits, 255, 8 bits, 255. So by this time you are a little bit comfortable with this table. 1 bit if you add 128, so the subnet mask is 255, 255, 128.0, because as per our table, if I add 1 bit, it will be 128, that is 128 bits. 8 bits, 255. So again in A class also you can see all the calculation is the same, except the number of bits, host bits and network bits varies depending upon the class. So depending upon the class, the number of host bits and network bits varies, but the entire step-by-step calculation remains the same. So, okay, so once we do this, the next thing, Subnet mask calculated. How many subnets we did not calculate. Subnets anyway not required to calculate, but it's very useful, especially when you get into certificate exams where you will maybe tested on some questions where he may ask you how many small networks I get if I divide with a requirement of this, something around that. So it's always good to calculate each and everything, so that anything, whatever the question asked, you should be in a position to calculate. So we'll try to get into that particular part, how to solve the bits and all those things, in the next video. In the next class we'll be focusing more in detail on that, but before that I just want to have a very good understanding on calculation process. So to the power of n value is your this is your n value, so to the power of 9, which means I get 512 subnets. Okay, so I get 512 subnets. So A class supports 16 million addresses in one network. In that 16 million, if I divide each network with a size of 32768, I get exactly 512 subnets. So if you just want, you can multiply this, you get exactly the same number what we discussed. This is the number we get. But anyway, we really no need to do all this multiplication and subtraction divisions. By using this simple formula 2 to the power of n, we can easily find how many small size networks we get after dividing. The last thing is writing the range. So when you are writing the range, again we have to take the same step-by-step method which we learned. If you remember, when you are writing the range, we always need to make sure that we use 2 to the power of h value, where 2 to the power of h value, the h value is, I think it's 15, right? Yeah, you can see this is 15, h value is 15. So 2 to the power of 15 is 32768. So 32768 is the size of the network. So whenever you're writing the range for bigger numbers, like I'm going to take any A class example, that is A class is 10. Any A class example, the first portion remains the same, 10 remains the same. So the first address always starts on 0.0.0. In the next range, next address will be based on 2 to the power of h divided by 256. So in my example, 2 to the power of h divided by 256 means 32768 is the 2 to the power of h value divided by 256. So it's very simple division. In 1000 I get 4. In 32,000 I get how many? 32 into 4, it becomes 128. So I get 128 blocks of addresses are required in order to have 32768 addresses, which means I need to just add plus 128 in the next portion, in the third portion, to get the next possible size. So next possible size is 128.0, which means my range ends on 0.127.255, and it ends on 10. And plus 128 here, plus 128 become 256. Plus 128 become 256, but the question is there is no address with 256. Anyway, I'll come to this. Let us write down the last range. So anything before 256 is 255. Anything before 0 is 255. So which means I'm done with all 10.0s. So once you finish this portion, 255, now in the A class we got one more portion to utilize as a host, this portion. So first we are utilizing it with zeros. Now again, so I'm going to write again, just a minute, let me just come down to this example one more time. So next range will be 10.0.255.255, and once you finish this portion, now again we have to write the same number with 10.1.0.0 and 10.1.128.0 is the next network. And once we finish this 10.1, we have to write 10.2, 0.0, 10. Like this. If you go on right, you get exactly 1 to 512 networks actually. So 512 networks, but no need to write those 512 networks, but it's very important to know the range. Like that, if I go on, the last network will be 10.255.0.0 and it ends on 10.255.128.0, and the last network will be 10.255.255.255. So if you just go on right, you get exactly 512 networks. So when you're doing any A class example, this is the method we write the range. This is the way we write the range. But again, when you're writing the range, always we increment here. So Finally, there are few important points we need to keep in mind when you're writing the range. So this is something which you have to keep in mind. So let's say we got first portion, second portion, third portion, fourth portion. We got 4 portions here. In IP address we got 4 portion of addresses. So whenever we are writing the range for any number less than 256, less than 256 means it can be the size of 128, because less than 256, that is the next size. If we refer our table, less than 256 means the size can be 128, or size can be 64, or it can be 32, it can be 16, whatever size. If it is less than 256, whenever we have a requirement of less than 256, always the range we need to write multiples on the 4th portion. Because less than 256 means, if I say size of 128 means the first net will be 0.0, that's what we write, 0.0 and 0.128, right? If I take a requirement of 64, I write 0, 64, 128, 192, multiples of 64. Similarly, if I take multiples of 32, 0, 32, 64, so we write only this 4th portion on this 4th portion here. But whenever you have a requirement of anything, this is wrong actually, it has to be less than 256. Anything less than 256, okay? So anything less than 256, we always write increments on the 4th portion. And anything if it is greater than or equal to 256, we need to write the increment on the 3rd portion, this portion. Because if I take the size of 256 addresses, so 256 means 1 block we require, which means it will be 0.0, 1.0, 2.0, 3.0, like that. The range will go on like that. So these are the summary points which we need to keep in mind whenever we are writing the range for this type of numbers, especially very useful in shortcut methods. So anything, let's say if I take the size of 2000, or if I take 1000, if we remember we did this example previously for B class, the possible size is 1024, which means I need 4 blocks of addresses, because divided by 256 I get exactly 4 blocks. So it write multiples of 4 on this, which means 0.0 is the first range, second range will be 4.0, third range will be 8.0, like that it will go on. Similar way, if I take a requirement of any other requirement, like we did just now we did 32,768 divided by 256, blocks of 128, so we write 0.0, we write plus 128 here, 0.0, 128.0, like that. Okay, so in case if you have a requirement anything greater than or equal to 65,536, then we need to increment on the 2nd portion, because many people have a wrong conception that if you are doing any A class, any C class example, we have to increment here, any B class example we have to increment here, any A class example we have to increment here. It is wrong. So that's not correct. The increments depends upon the size of the network. If you have a requirement of less than 256, we increment here, that is multiples we need to write here. If you have a requirement more than 256 or equal to 256, anything less than, in bit less than 65,000, so we increment here. And anything above 256, because when you write these two blocks nothing but representing 16 bits, so 2 to the power of 16, 65,536. So whenever you get a range more than 65,536 or 65,536, then only we need to increment on this portion. That is very, very rare you'll find such a big size networks. But calculation wise, maybe you'll be tested in your interviews, or maybe when you face some written tests in the interviews, or it can be certification exams, or it can be any network design implementations. So these things which really help you to remember and to summarize how the process goes. So these things are very important to keep in mind, but before this you should have a very good understanding on how to write the range. That comes only when you start practicing. Okay, so this is something about A class. Similar way, I suggest you to try some A class examples, like you can take a requirement of 65,000 first requirement, and you can take a requirement of I think we did in B class 8,000, so I can take a requirement of 8,000, and you can take a requirement of 2,000, something like this. Just try to work on some these 2-3 examples relating to A class, just to have a very good idea and on how the calculation goes, because the next part which we'll be discussing is VLSM, variable length subnet mask, and you should have a very good clear understanding on this part. And also we'll be discussing in our next class some shortcut methods for doing this subnetting. So for those shortcut methods, these this whatever the tips I gave here, these things, and using this 2 to the power of h value, and how many bits converted, and what is the subnet mask, this understanding is very important. If you don't have a proper understanding on step-by-step calculations, it becomes very difficult for you to follow the shortcut methods. So you'll never master the subnetting, because many people say that there are many subnetting calculators available on the internet which can give you some idea on how the calculation goes, but the same thing you can do on your own, because when you face examinations, when you face any interviews, probably you don't have access to those things. That is okay, but the same thing what a subnetting calculator can do, you can also do on your own. So I'll give some idea on subnetting calculator, how it works, just in the next class. We'll get into that when we use some shortcut methods and we try to solve our questions. Okay.